John, you said that the electron would go at the speed of light. Surely the mass in the electromagnetic field of the electron would have to still be there, and therefore the electron would not go at the speed of light if the Higgs did not exist.
No. The mass of the electron would remain zero if you had no mechanism for triggering mass generation. And that would be because of chiral symmetry.
So what are you doing about the field of the electromagnetic mass of the electron?
So if you wrote down QED, okay, with a zero mass electron, and if you went through the standard renormalization program of quantum field theory, you would never generate an electron mass.
That doesn't answer my question. What do you do about the fact that the electron has an electromagnetic field which certainly has mass?
This comes back to this question of renormalization.
Yes.
Okay. And I already sort of flagged the fact that one could worry about renormalization. Certainly Dirac worried about renormalization. And he wanted a finite theory so that you wouldn't have these infinities that you sweep under the rug. So John told us that there was another meeting about infinities and under rug sweeping. So I'm not sure whether this is the right place to debate it. I am somewhat in sympathy with Dirac's point of view. And that's one of the reasons why I like string theory, which is maybe an unpopular thing to say nowadays, but I still like string theory because it does promise to provide you with a theory which is ultimately finite and in which you should be able to calculate absolutely everything. Maybe in terms of some limited number of constants, I don't know. But at least, I think that would provide a scenario where everything would be calculable.
Thank you.
Just a short question. The number of generations you would also consider as fundamental constant to be explained?
Yes. Well, I mean, the number of generations spawns a whole number of fundamental constants, right? The masses and the way in which these guys mix. So you can regard the number 3 as being a sort of parameter, although it's an integer, so I wouldn't regard it in quite the same category as the other fundamental constants that we've been discussing. But indeed, that is a parameter of the theory that we have no clue about. Well, there's lots of speculations, but I don't think any of them is worthy of consensus.
So all the parameters have now been calculated for the standard model, and you said not until recently have the last 2 lines of the Lagrangian had any sort of direct evidence. Given that, what can the standard model now tell us? Is it basically told us all that it can tell us, or is there more to it now that we know all these parameters?
I think that these constants are trying to tell us something. Okay. And I think it is our scientific responsibility to measure those parameters as accurately as we can. That's the only way in which we're going to get any clue as to how the theory works, right? It's a little bit like the sad story of this Malaysian airplane, right? You really have to analyze the radar signals with high precision in order to figure out exactly what happened. So it's very much the same thing here, okay? I think we on the one hand, need to measure these parameters as accurately as we can. And of course, in parallel, we look for signs of other phenomena beyond the standard model. And but there's all sorts of reasons why there must be something beyond the standard model. I mentioned dark matter. There'll going to be another story related to the top mass coming tomorrow. So there must be physics beyond the standard model.